class. Today we're looking at Chapter 8, Lesson 4, Data Variability. Ooh, that was a hard word to say. So you can use random samples to compare two populations. A box plot uses 5 points on a number line to summarize a data set. Let's write that down. So a box plot uses 5 points on a number line to summarize data. The box shows the middle 50% of the data. With a box plot, you can observe the visual overlap of two data sets. So this was the least value, the greatest value. So the least value is 1. The greatest was 11. The lower quartile was 4. The upper quartile is 8. And the median, the absolute middle, is 6. So the interquartile range, or IQR, of a data set is the difference between the upper and lower quartiles. So the difference between the upper and lower quartiles. So if you look at this one, the upper is 8, subtract 4 equals 4. So the IQR is 4. The IQR is one measure of variability, which tells how much data set is spread out. So variability tells how much a data set is spread out. So now let's look at this one, comparing two populations. A veterinarian collects data about the weights of dogs she treats. Compare the IQRs of the data sets to draw an inference about the dogs. So if you look here, Boston Terriers, right? So the interquartile, the IQRs. So for this one, and I'm doing the Boston ones first, it's at 20. So you go 20, subtract 17 equals 3. The IQR for the Boston Terriers is 3. And the IQR for the Australian Terriers, 14 minus 11 also is 3. The IQRs of the data sets are the same. You can infer that the weights of Boston Terriers vary by about the same amount as the weights of Australian Terriers. So now what I'd like you to do is compare the median of the data sets in example 1 and use a comparison to draw another inference about dogs. Think about that for a minute. Press pause, think about it, see what you come up with. Come back to me when you're done. Okay, so the median weight of Boston Terriers is 19 pounds and the median weight for Australian Terriers is 13 pounds. Therefore, Boston Terriers must usually weigh more than Australian Terriers. So you're just stating what you've come up with based on the information. Okay, so mean absolute deviation. A second measure of variability is mean absolute deviation, or MAD for short. The MAD of a data set is the average distance between the mean and each data value. So the mean absolute deviation is the average distance between the mean and each value. So you can determine the amount of overlap of two data sets by expressing the difference between their centers as a multiple of the MAD or IQR. A multiple less than 1 indicates a large amount of overlap. A multiple greater than 1 indicates a small or no amount of overlap. So the data table here shows the number of points scored by each player on 2 basketball teams during a game. Use measures of center and variability to express the amount of overlap between the data sets. So the first thing, calculate the mean of each team. So let's start with the Eagles. So they had one basket that was 4. Two that were 6. 2 that were 7. 1 that was 8. And 2 that were 9. So we're going to add all these numbers together. And when we add them all together, we should get 56. And there are 1, 2, 3, 4, 5, 6, 7, 8. Divide them by 8, which equals 7. So our mean for the Eagles is 7. That wasn't even in where you could see it. Okay, so now let's do the same for the Vikings. So Vikings, there were 0, 0, 1, 2, 2, 3, 4, 4. When we add all of those together, 8, 9, 10, 11, 12, 13, 14, 15, 16. And there are 1, 2, 3, 4, 5, 6, 7, 8. Divide by 8 equals 2. So the mean for the Vikings is 2. So now it says determine the MAD of each data set. Okay, so the best way to create or to find the MAD is to create a chart. So we're going to do the points. Oops, it helps if I have the right tool. The points. So this is going to be for the Eagles. The points, the mean, and then the distance between. So, right, I have the points listed up here. So 4, and then the mean was 7. So the distance between 4 and 7, if you subtract those, you get 3. So then we have 6. This is still 7. 1, 6, 7, 1, 7, 7, 0, 7, 7, 0, 8, 7, 1, 9, 7, 2, 9, 7, 2. So just to be clear, these are all the mean. I got the mean from up here. These are the points. Here are the points. And then this bottom number is just me subtracting these. And it doesn't matter. Leave the negatives out. It doesn't matter. So then once you have that, this orange line, you're going to add up the total of each of those. So if I add all these numbers up, 3 plus 1 plus 1 plus 1 plus 2 plus 2, that equals 10. So I'm going to just put MAD equals the total of distance. So the distance is just the difference between numbers divided by the number of values. So 10 divided by, and there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 values. So when we divide, 8 goes into 10. If I divide that out, it equals 1.25. So the MAD for the Eagles, is 1.25. So you would want to do the same thing for the Vikings. And so 2 is the number. So I can just literally go 0 subtract 2 is going to be 2. Oh my goodness, why do I always do that? So we have 2, 2, 2 subtract 1 is 1, 2 subtract 2 is 0, 0, 3 subtract 2 is 1, 4 subtract 2 is 2, 4 subtract 2 is 2. Add these together, 4, 5, 6, 7, 8, 9, 10. 10 divided by 8, there's still 8 of them. No. Yeah. Oh my gosh, and look it equals the same. So therefore, their variability is similar. So what multiply of multiply, is that was multiple, sorry, spelled wrong, should be an E here. What multiple of n of the MAD equals the difference between the means? So MAD, so the MAD times n equals the difference. So we're going to plug in 1.25 times n equals, and so then we do the difference. So the mean of the Eagles was 7, the mean of the Vikings was 2. So 7 minus 2. So we have 1.25n equals 5. Divide by 1.25. Therefore, the n equals 4. So what does this number tell you about the overlap of the data set? The difference between the means is 4 times the MAD. That's what it tells us. The difference between the means is 4 times the MAD. So the distance between the centers of the data is greater than the variability of either data set. This is a little overlap in the data set, which the data table confirms, right? Because this is the only overlap right here. That's not much at all. Okay, so the difference between the means is 4 times the MAD, and the distance between the centers is greater than the variability. Okay. Okay, now it wants you to try it, and that was kind of crazy, so do refer to your notes there. See what you can come up with, A, B, and C. Like I said, go back to your notes. Come back to me when you're done. Okay, so Station A's mean was 36, Station B's was 35, Station A's MAD was 1.2, Station B's MAD was 1.2. So for C, it was 0.8, and 0.8 is less than 1, so there is a lot of overlap. Be sure to refer to these notes for the homework assignments. Re-watch this video if you need to. So your homework for today is homework page 299 through 300, numbers 3 through 11 odd. Happy homeworking!